All right, hello everyone. Welcome to Run Spline. I'm just going to do a quick audio check, make sure that it's transmitting to the YouTube stream. Make sure that's good. All right, hello everyone. All right, looks good. So I'm using the DJI wireless mic right now. It's all charged up, so we're good to go. So today's live stream is going to be a speed run of Spline. So what is a spline? So a spline is, there's common architectures we have for doing any kind of network deployment with any kind of switching gear. There's the collapsed core. Arista calls it a layer 2 leaf spine. Layer 3 routed. Layer 3 EVP and VXLAN, and there's two variations of that topology. And then spline, actually should be spline. There we go. And spline. So layer 3 leaf spine, that's pretty familiar to us. The big thing here with a layer 3 leaf spine is that every rack or every leaf or leaf pair is a separate subnet. So that works fine for some workloads, but most workloads, you're going to need that workload mobility. We're going to have the same layer 2 network is available everywhere. So that's what we get in the 3-tier architecture. We've got the core layer, we got the aggregation layer, and then we get the access layer, with the first hop being the aggregation layer. And then we got L3, layer 3 leaf spine with EVP and VXLAN, and the MLAG variation. So that's when the two spine or two leafs are together in an MLAG pair. And then, I thought I had a... Yeah, there's one where we do EVP and all active and there's no MLAG. Anyway, so what is a spline? Spline is it's just two switches. That's all it is. And it's really common in small deployments. If you just have two switches, you've got 10 ESXi hosts, 15 ESXi hosts, a couple other devices, and you need some kind of network. You don't want to do EVP and VXLAN in that situation, I don't think, because it's going to be too complicated. You need to have two devices. Arista didn't invent spline. They invented the term. I don't know if they invented the term, but they trademarked it, I think. And it's where you've got two devices just in an MLAG pair, and then it's also the first hop. That's where the default gateway is. And you connect it to hosts, typically multi-homing, but it doesn't have to be multi-homed. These could be top of rack, end of row switches, or they could also be just big chassis switches, and that's all you want is just two chassis. We did this a lot. This very architecture was very popular in the 90s, because in the 90s, going past a layer 3 boundary or going past a layer 2 boundary into layer 3, there was a significant limit in forwarding speeds of layer 3 compared to layer 2. So we would often have these Catalyst 5000s or 5500s and then 6500s acting as the spline, and we would just connect a bunch of hosts to them. So this has been around for quite some time, with the exception of the splines being in an MLAG pair or whatever the generic term is, MLAG or MCLAG. It wasn't really around back in the 90s, but this is pretty much how we set things up. Instead of dual homing, half your hosts would be plugged into one and half your hosts would be plugged into the other. So it's relatively easy to do. It's pretty much the same as doing the collapsed core. So let's do the collapsed core. So the collapsed core is when we get rid of the core and the aggregation layer basically become the same thing. So that would be core 1. You can call them whatever you'd like. That's where your first hop would be. So that's a collapsed core, and then VPN all active is you just don't have pure link in there. So just fill that all out. So, but we're going to go with this. And the first thing we need to do is I need to make this actually in Container Lab. So we're going to use Container Lab to do this. Set this for live. Welcome to, and what do we need to do here? We need to pull up. So I get looking at my my Proxmox setup. Figure out which one of my VMs is running. 144. Okay. So we want ZSH. Don't know. I thought I had ZSH in here. Anyway. Yeah, so I've got, do I have, is that the one I want to use? Or do I want to use this one? Yeah, I could have sworn I had ZSH installed. All right, we'll use this one. Let's see if I'm running sudo docker ps. Okay, I've got no Docker images running on here. So we're going to use Container Lab. And I'm going to create a new Container Lab topology. So I have a GitHub repo. And it's the Container Lab topologies that I use for my particular environment called Nerd C Lab Topologies. And then I'm just going to start over here. So that way I've got a fresh starting point, and then I'll create Spline. I'll copy this. Let's go copy this right here. Spline CLab to YAML. And this will show how everything is connected to each other. The first thing I'm going to do is make sure I've got see which sudo docker image list. See what versions I have installed on here. So I've got the, I don't know if that's the most recent version, but it's a pretty recent version. So I'm just going to switch to this. So I'll do change all occurrences, 35.1 Foxtrot. So that'll load all that up. We're just going to do 2 splines, so I can get rid of all of the leafs. And we'll just call it Spline 1 and Spline 2. So those will be the management addresses. I didn't do IPv6, but now I'm kind of like, do I really want to do IPv6 now? Because I'm starting to play more around with IPv6. So let's go ahead and give it an IPv6 address. Documentation IPv6. What's the documentation address? Documentation prefix. So 2001 DB8. Yeah, two movie references. 2001: A Space Odyssey, and then DB8 is the, I think it's from James Bond. Yeah, let's go with that. Let's use the first. Yeah, we'll do that one. All right. I don't know. I think that's the other documentation prefix. Because 3FF. Yeah, so rather than use that, I'll just make that just to let everyone. I wanted to pick something that was like management, indicating that's a management network. Okay, so we'll do that, and it'll auto assign. Hopefully, we'll see. Again, I'm still pretty new to working with IPv6. If that gives you any indication. I got my gas station coffee. My friend got me this. It's a I don't know if you know the quote. It says, eat your cereal with a fork and do your homework in the dark. If people know what that came from. It's a movie from the late 80s, early 90s. Cereal with... Okay, so we got that. So Spline, we're gonna do hosts and 2 routers. I really want you to do AI. And I don't really want to do AI. We'll do 2 hosts of type we'll do 2 hosts of EOS type, and then we'll do 2 hosts of will be Alma Linux. Alma Linux latest. Let's see if that'll work. So we are going to do 4 hosts because we only got 2 splines. We got plenty of RAM to work with. So I'll go ahead and do 2 hosts so we can see how we connect, how we do home Linux systems. And then this part right here is going to be kind of cray. I'll just start here. Spline 1, Ethernet 1, Ethernet 1, Spline 2, Spline 2. Yeah, Spline 1, Spline 2. Then it would be Spline 1, Ethernet 3. Let's get rid of these. Doesn't really help us. Spline 1. So Spline 1, Ethernet 3 will be host 1, Ethernet 1. And then Spline 2 will be host 1, Ethernet 2. So that'll be 1 host. And then the other host will be Ethernet 4, host 2. It's easy to get lost in all of these. Ethernet 5. Ethernet 6. All right, let's see if that'll work. So we'll go into Nerd Suite Topologies. We'll go into Spline. We'll do Container Lab Deploy. Okay, type all Linux is not supported. Maybe just Linux. Pull overlaps with another address in the space. So that sometimes, oh god, that one always got me mixed up, and I think it's because there's already a V switch, already a switch in Docker. So Docker network list. Yeah, so I think it's management 2. So Docker network delete management 2. Remove management 2. Docker network help. RM. Oh, yeah, that's because I've got... All right, so I just need to go in and destroy those. Ah, crap. Yeah, because I renamed the directory. There we go. All right, gone, and just so we got things right here. Put that to old. And CLab deploy. So far it's working okay. I really like this mic. I am quite enjoying it. Oh, you know what I forgot to do? I did not connect the routers, R1 and R2. So I got to destroy and recreate. So that's R1 and R2 right there, connecting to our splines, just to provide a routed network. And then what I also want to do is have a, just have a host, remote host 1 connected into one of the routers. So I want to do that. So I got to put that into, so I'm going to do CLab destroy. Just kill all that. So Ethernet 7 be R1 and R1. R2. And then I'm going to create an R remote host. more in this vein. $51. Yeah, we can use that one. Make sure we got everything. So this is our host one. Okay, so and then so they'd be only on non-symmetry. Ethernet 9. Host 1. Ethernet 1. Is that what I called it? Our host 1, yeah. All right, let's do deploy again. Unable to find host R1. Oh yeah, it's case sensitive. If you haven't used Container Lab, I would highly suggest giving it a look, especially if you're using Arista. It is by far the best way to practice with Arista. There are images for Cisco. It runs a VM inside a container, which is kind of weird. And also images for Juniper. Juniper has the worst of the virtual instances. They do have a containerized version, but it's like Cisco. It's a VM running inside of a container. It's a little bit easier to set up than Cisco. So it's CJUNOS evolved, and so it's a little bit easier to set up, but it's way more resource intensive. It like eats up a ton of CPU and RAM. So it's a little bit problematic in that regard. EOS, if you get the 32-bit version, now they're still releasing the 32-bit versions. At some point they might stop, but right now they're still releasing the 32-bit versions. If you get the 32-bit version, it only uses up about a gig of RAM for each instance. So if you have 16 gigs of RAM, you can run like 13, 14 images and still have room to do other stuff, or so much room for other activities. Okay, so that's all set up, and looks like we've got our addresses in here. So let's go to Spline 1. Oh yeah, what I want to do is I want, I've got an inventory file here. Well, I got this part of inventory file that I'm going to copy because I want to set all this stuff up. So I want, did it create a, yeah, CDC lab. Son of a bitch. Okay, C lab destroy. I gotta clean this up. So what I did is I didn't rename this part right here. So this is gonna be Spline. Because I want the directories to be correct. All right, so CLab deploy. So CLab Spline. So there's CLab Clos Medium, or Clo Medium, not Clos, Clo Medium, then CLab Spine. So then I've got my, oh yeah, inventory, just gotta set that up. I'll just do inventory.yaml. Like, why do we have to, what is with all the AI stuff? It's like begging me to do stuff with AI. I'm just creating an inventory Ansible file, Ansible inventory file. We don't need to get AI involved in that. Chill. Is there a way to disable all this stuff? Is there like an AI off button? I really wish there would be. So these settings here tell Ansible to use the eAPI instead of going in via SSH. And it also tells that it's not like a Linux server. It's a EOS host. Different vendors will have different ways to get in. With Arista, it's through HTTP API drivers. If you're going to be using Juniper, I think they use netconf. Okay, so the inventory Ansible inventory file is here. We don't care about that. So I'm just going to copy all this stuff to Ansible inventory. It's nice that it automatically creates an inventory file. What in the heck? Indentation was weird. Oh yeah. That one needs to be moved over. Okay. Yeah. All right, so that's good. And interestingly enough, it used all of the IPv4 addresses. It didn't use any IPv6 addresses. So there's no vars for the all, just for EOS. I think that's what we want. And then I will, it does have some authorized keys. Did it put the authorized key? It did not. Okay. So I've got a playbook that I use just to configure the hosts, set up nodes. So it uses this stuff here. That's like a quick setup that I kind of a universal setup that I do. I've got an ordinary inventory in here now too. Why did you do that in YAML? That's 4 spaces in YAML. That's no good. Okay. Now we're going to set up. Most of this is going to be just the setup of the environment, the setting up of the container lab, because the rest of it's going to be really easy. Of course, I say that, but. I need to create an inventory, an Ansible inventory. Why am I saying inventory? So Ansible config. I like having Ansible config files because they just tell you where to find everything. And it'll look it up in the local directory. Generate code or select language. Start typing to dismiss or don't show this again. Cool. Do not want to see that again. Yep, inventory. Actually, we want to do with Ansible inventory. It actually did a really good job of creating one. Ansible inventory. Host key checking is false because we're just telling it not to worry about the fact that we haven't, like you get this error here. So SSH admin at Spline 2. You see warning permanently added. So Ansible will stop if you get that warning, unless you say host key checking false. And then gathering explicit just tells it we're not going to gather facts because and for the EOS devices, we can't, there's nothing we can gather. All right, so Ansible playbook. Set up. Oh yeah, I need to copy that over. So that would be Ansible. It's not in there, it's in topologies old. Set up nodes. And what this does is it just logs into each device and then sets a couple accounts and stuff. We won't do it for all, we'll do it for CEOS. So that'll be the group that I created. So it creates user Tony, copies over my SSH key, and then set some configuration stuff. We don't really need token stuff. I want to leave that in there because it's a good reference, but setup. Where did I put that? I'll put that under here, CLab Spline. All right. R1, R2, host 1, host 2, R host 1, Spline 1, Spline 2. Okay, good. There are the host 3 and host 4. Connection refused. We'll configure those last. Okay. Another sip of my gas station vanilla coffee. So when we're ready now to configure the spline, which is going to be pretty quick. Famous last words. First, we're going to configure mlag, and that's going to be the peer group, or the peer link, mlag, VLAN, SVI, and then mlag config. Then we're going to configure VARP, and the Anycast, or the VARP, VARP IP. Turn on IP routing. Then we're going to configure routing to R1, R2. And then configure hosts and R hosts. So first thing we're going to do is configure the peer link on both sides. So I'm gonna get rid of that one. I'm gonna SSH into host to Spline 1, and then I'll log in over here and SSH into Spline 2. So here we'll do interface, we'll do show LDP neighbors just to verify that Ethernet 1 and 2 are connected to the other spline. So 1 and 2. Channel group 2000 mode active. Interface port channel 2000. Then SSH, interface E1 through 2. Channel group 2000 mode active. You don't have to use 2000 as the port group or as the channel group. That's the lag ID, the lag interface. And if I do show interface port channel 2000, because both sides are now setting LACP PDUs, they should be up and running. We can verify this by doing show LACP peer. We can see that the other side, so we're bundled. As a reminder, that's all LACP does, is it bundles, it determines whether or not a link's going to be active in a lag or not. You configure the lag. Without LACP, the lag works exactly the same, except without LACP, if you get a link light, you're good. It'll send traffic over that link. With LACP, it's going to check to make sure that all the links match on their system ID right here. That's what it's looking for. So they all match, so it's part of it. So that was easy. Then we configure the, so we'll put VLAN 4094 in the VLAN database. We'll do interface VLAN 4094. VLAN 4094. We need to configure a IP address. Do we want to do IPv6? Was IPv6 DB8 or DB9? 2001. DB8, okay. Let's do 999. Let's do 2000 because that's the /64. Ambiguous command. Oh yeah, there we go. So we'll try using IPv6 addresses for funsies. And no auto states. And then interface port channel 2000. Switch port mode trunk, switch port trunk allowed VLAN 4094. So we'll do interface VLAN 4094, put it in the VLAN database. Oh yeah, we need to turn off spanning tree for this too. So no spanning tree, VLAN ID 4094. So interface VLAN 4094, no auto state IPv6 address 2001 DB8 2002/64. It's so weird. It's so weird using a /64 for a host address because it seems so wasteful. But that's what they wanted to do. I could do a 127, but not really necessary. No auto state interface port channel 2000 switch port mode trunk, switch port trunk allowed VLAN 4094, and then no spanning tree VLAN ID 4094. So that turns off spanning tree for VLAN 4094, which is what you normally do for MLAG. VLAN 4094 is only going to be in these two switches. It's not going to extend beyond it. So we don't need spanning tree for it. And it should never go on any other trunk port. It should never go anywhere else, just between the two devices. So I'm going to do ping 6, ping 2001, DB8 2001. Okay, so we can ping the other side. So that looks good there. And now we can do the MLAG configuration. So local interface is a port channel VLAN 4094. Peer link is port channel 2000. Peer address is 2001. DB8 2001. Okay. MLAG configuration. Local interface is VLAN 4094. Peer address is 2001. DB8 2002. Peer link, port channel 2000, show MLAG. What am I missing here? It's disabled. What was the, because I had some, sometimes I forget the MLAG configuration.
Look at my notes. No, I got a configuration in here somewhere. Oh, domain ID, that's it. MWAG. There we go. It was just as simple as one command. All right, consistent, and we're connected. So I used IPv6, easy peasy. All right, so that's that, and then we need to do configure VARP. So we'll do IP routing to turn on IP routing. That's a problem I had last time. Then I'll do interface VLAN 10. We didn't assign any addresses, so let's put them on different VLANs. So we'll do. And part of the reason I'm doing this is just to find the style that works well for this kind of thing. So I'll put them on two different VLANs. Interface VLAN 10. IP address 10.1.10.2. And then, oh yeah, we need to do IP virtual router MAC address 00 Charlie 73000099. IP address virtual 10.1.10.1. IP virtual router address 110.1. All right. That's spline 2. Actually, it's supposed to be this address. Let's use VLAN 10. IP address 10.1.10.2. IP virtual router MAC address 00 1 Charlie 73. I have that number memorized from doing this so much. And then IP routing. Yep, it's already there. So show IP. So that should be good there. I'll do the same thing for VLAN 20. And at 1.20.3. I do show IP, show virtual router. State it shows this stopped. Yeah, probably because it's not active on any interfaces. So if we do show LDP neighbors, I've got R1 and R2 connected. Host 1 and host 2. Host 3 and 4 are connected, but they're Linux systems right now. They're not running LDP. So we will turn that on. We'll actually enable it. It actually works out pretty nice. Interface E3 is switchport mode access. Switchport access VLAN 10. Okay, yeah, we didn't put it in the VLAN database. All right, now it is. And then mlag 10 or mlag. Oh, shoot. Didn't mean to do that. So no interface E3. Interface E3. Show run interface E3. Okay, I just note out all the options. So channel group 3 mode active interface port channel 3. Switch port mode access support access VLAN 10. And then mlag 10. And E4, switch port or channel group 4 mode active. Switch port access interface port channel 4, switch mode access, switch port access VLAN 20. And then mlag 4, interface port channel 3, mlag 3. I made a mistake there. Okay. So show interface E3 through 4. Show run interface E3 through 4. And show interface port channel 3 through 4. Show run interface. All right, that looks good. Let's copy that. E3 channel group 3 mode active. 4 channel group 4 mode active, and then just paste that. All right, so show IP virtual router. Show VLAN. Run interface port channel 3 through 4. So yeah, they're not running. That's fine. SH host 1. Active. All right, links up. All right, shows active. Should be pinging now. In the virtual environment, sometimes it takes a while for the ping to go through. So we did get an ARP response. That's weird. Couldn't get a ping from the default gateway. Let's see if I can ping the other side. Nope. MAC looks good. Show MAC address table, VLAN 10. Okay, we got that there. It's weird I can ping the default gateway for 20, but not for 10. sure they're plugged in right. And show interface port channel 3. Looks good there. Oh, you know what? I think do I need to do this? Is switch port trunk allowed VLAN add 10 and 20. Thousand switch port trunk allowed add. Port trunk allowed. VLAN add 10 and 20. No, that was it. Okay. Good to know. I thought it was behave the other way. All right, now they can ping each other. So that's all done. I'll do a quick write and write and write and write. Yeah. So configuring configuring this is relatively easy. Yeah, we're using VARP and not VRP because there's no reason to do VARP in this scenario. Or sorry, there's no reason to do VRP. Because when we do VARP, with VRP, only Spline 1 or Spline 2 is an active forwarder. The other one just, other one doesn't really care. The other one's standby. But with VARP, they're both active. Let's check in my notes, make sure I didn't forget anything. All right, so now we're going to do a couple extra things. We're going to configure routing to the routers. So I hate this. Open chat. I'm on a command line. What do we need to get involved in this? All right, so it says, at least it says don't do this again because I really don't want to do it again. Okay. R1. Try that again. R1. Interface, show LDP neighbors, Spline 1 and 2. So we need some IP addresses. We'll go ahead and do some, we'll just do IPv6. We won't get too fancy here. I'm sorry, IPv4 rather. 10.150. 10.150, 10.150/0/31. /31. Two. 3. 4. 5. 6 and 7. All right, so interface, E1, no switch port, IP address 10.150/31, interface E2, IP address 10.152/31, no switch port. Two. Switch port, IP address 10.154. Face E2, IP address 10.156. Switch port. And then spline 1. Show LDP neighbors. No switch port. IP address 10.151. E8. Switch port IP address 10.154. So it should be able to ping 10.150 and 10.150. Oh, I did it wrong. You're probably screaming at me. 5. Okay. Then over here, switch port, switch port. Okay. All right. So the point-to-point links are configured.
Now let's do the routing. We'll just do areas 1. Router BGP1, router ID. Just made one up. Maximum paths 2. Neighbor 10.150. Node AS is our neighbor peer. Neighbor R's. Core, we'll call it core. Peer group. We'll do a peer group. Neighbor 10.150 peer group core. And 5.4. Neighbor core remote AS 1. Then address family IPv4 neighbor core activate. Let's go to R1. Router BGP1. IP routing. Router BGP1. Router ID. Router IDs don't actually have to be active IP addresses. It's probably a good idea if it is, but they don't actually have to be active IP addresses. I just made them up. The 4 could do your homework in the dark. That came from. It's a movie from the late 80s, early. They don't actually have to be active IP addresses. I just made them up. Okay. And then 10.1.5. Look at my chart here. 151. Peer group core neighbor 10.1.5.3. Peer group core. All right, so we're configured. So now we just do the other sides. It's kind of tedious. IP routing, or it's already there. Router BGP1, router ID 222, maximum paths 2. Neighbor 10.1.5.2, peer group core. 10.1.5.6. Established. And then finally here. So router BGP1, IP routing, router ID 22. Just make sure they don't overlap. You don't want colliding router IDs. It's very bad. All right, there we go. Just took a second. And unless router 1 and 2 connect to each other, they're not going to, router 2 is not going to be, I realize router 2 is insignificant, doesn't do anything. So what I'll do is, I won't do anything with router 2, but our host 1, I thought our host 1 was connected. Oh, it's connected to Spline 1. Oh, shoot, I connected it to the wrong one, the wrong device. Crud. So I wanted to if I redo everything, it's not going to save the configs. But I could use automation and fix this, because I do want to put this on GitHub. All right, I'm gonna do a bio break. Be right back. Be right back. I'll take this off. So I don't accidentally take this to the bathroom. And a back. All right, so what I'm going to do is I'm going to back up all the configs. I can do that with a quick playbook. Should be a quick playbook. Yeah, backup configs. Let's put this in here. So what I need to do here is make directory configs, an original, and an Ansible playbook, backup. Spline. Playbook, backup configs. So created a directory called configs and original, and then there they all are. So I can upload them a little bit later. All right. Because I need, I did a boo-boo. And I need to plug router 1 and router 2 into each other. And I need to plug our host into R1 instead of the spline. So just made a little mistakey poo there. So our host 1, that should have been R1. R1 Ethernet 3. And then R1 Ethernet 4 to R2 Ethernet 3, because that's not plugged in anything. All right, so what I don't know is I'm going to do CLab destroy and then deploy again and see if the configs actually get saved. I don't think they will. Maybe deploy and I do reconfigure. Let's see. Add the configs at least. I was doing this all manually. Drinking spicy water. I like to joke that I used to have a Coke problem, and that I was drinking like 40 ounces of Coca-Cola per day. Lime Coke was my favorite when it was out. They've since discontinued it, unless it's a diet, and I hate Diet Coke. Coke Zero is actually not too bad, but that was in my 20s. Now I'm pushing 50, and I can't take that much sugar. So I am addicted to sparkling water. So just sparkling water with a little bit of orange flavor. It says naturally flavored. I don't believe it though. All right, so let's see. Spline 1. Nope, configs were not saved. That's okay. So Ansible playbook, and then we'll do setup nodes.
Oh no. It erased the directory. Well, that I learned something. I learned something very valuable. And that, because I saved the configs, but then they got erased when I did that thing. So I have to do all that over again. So, lesson learned. Is make an Ansible directory and keep everything in there and not in this. It was the reconfigure. I wonder if that erased it. Let's find out. Touch file name. So it created a file just called file name. It doesn't have anything in it. So let's do clab destroy. And then clab deploy. See if that erases it. I think reconfigure is... I thought reconfigure might save the config, but it actually just nuked the entire directory. Oh, wait a minute. Maybe I have... Yes. At least I have this. Kind of. No, that doesn't really help. I have one of the configs. If you're still watching, it's not a speed run anymore. It's a crap, I made a mistake. So it might have saved it if I didn't do reconfigure. That was a major boo-boo on my part. I'm glad it wasn't for something huge. Like, this is Spline. They're pretty easy to configure. For EVP and VXLAN, I think I'd be punching a hole in the wall. Trying to get comfortable, nice chair here. Okay. All right, so yeah, it was a reconfigure if that's what destroyed it. So let's do nards. Let's kind of start over again. We'll keep it in a separate Ansible directory. Then I'm going to copy over the inventory, this stuff. Don't need this stuff. All right. Spline 1. Oh, yeah. Oh, yeah, then I want the Ansible config file. And put that in there. We have a lot of stuff here. Agenda templates. Might as well do this one too. Backup configs. So Ansible playbook. Set up nodes. It just gives me an empty playbook. Oh yeah, that's right. I didn't copy the contents. Oh yeah, so the setup nodes, I just want to do it for CEOS. There we go. All right, so now I go to Spline 1. Looks good. Show LDP neighbors. That looks good. And let's go to R1. Okay, connect to our host and the... Yeah, and then I connect it to each other. Okay, so this looks good. We'll just double check with R2. Okay. Okay. All right, so I got to do this all over again. I hate that. But I haven't done this in a while, so maybe I could use the practice. All right, SSH Spline 1. SSH Spline 2. So we will go into config mode, and we will do interface E1 through 2. Channel group 2000 mode active. Config mode interface E1 through 2. Channel group 2000 mode active. There we are. And then we will VLAN 4094. No spanning tree, VLAN ID 4094. Interface port channel 2000, switch port mode trunk, switch port trunk, loud VLAN 4094. Let's do 10, 20, 4094. We're going to add those anyway. So VLAN 10 and 20. So that'll be in the VLAN database, so now they're there. And we'll do the same thing over here. So VLAN 10, 20. Interface port VLAN 4094, interface port channel 2000, switch port mode trunk, switch port trunk, VLAN 10, 20, 4094, and then spanning, no spanning tree, VLAN ID 4094, because we turned off spanning tree there. We'll do interface VLAN 4094, no auto state, IPv6. We'll keep with IPv6, DB8 2001 64. Oh, address. And interface VLAN 4094, no auto state. IP address 2001 DB8 2/64. IPv7. Oh, give it the right address. So it should be 2000. There we go. MLAG config. Domain ID MLAG. You can just set the domain ID to MLAG for everything. It's fine. Because the MLAG domain, it doesn't communicate outside of the MLAG domain, they can all be identical. With Spline, it doesn't really matter, but you can actually have a left side and right side config, or an odd or even config, and just copy and paste them everywhere. So you need two separate configs that are reciprocals, but you can just set them everywhere. Whereas Cisco VPC, the domain ID has to be an integer, and that determines the shared bridge ID, system ID, etc. So they do have to be unique, but they don't in Arista. So local interface is VLAN 4094. Pure address is 2001 DB8 2001. Pure link. Port channel 2000. Okay, that's good there. MLAG configuration, domain ID MLAG. Pure link is port channel 2000. Pure interface. Local interface is 4094. Pure address 2001 DB8 2002. Connecting. All right, and then always do a show MLAG sanity, or config sanity, just to make sure we didn't mess anything up. Okay, so we're good there. We'll turn on IP routing because we're going to configure VARP, and VARP requires that. It's something I found out last time. And then we'll do interface VLAN 10, IP address 10.1.10.3. IP virtual router MAC address is 00 1 Charlie 73000099. IP virtual router MAC address 00 1 Charlie 73000099. Get that right? Yeah. Again, I've configured that so many times I have it memorized. All right, interface VLAN 10, IP address 10.1.10.2, IP virtual router address 10.1.10.1, VLAN 20, IP address 10.1.22, IP virtual router address 10.1.21. Over here is VLAN 10, IP virtual router address 10.1. The shared address, they're both active. '23. There. And then the hosts, host 1 and 2. Interface E3 and 4. Interface E3, channel group 3, mode active, interface port channel 3, switch port mode access, switch port access, VLAN 10, MLAG 3, interface port channel 4, switch port mode access, switch port access VLAN 20, and lag 4. Interface 3, channel group 3 mode active. Interface port channel 3, switch port access VLAN 10, and lag 3. Interface port channel 4, switch port access VLAN 20, and lag 4. Show VLAN. All right, they're there and they're trunked. So now when I go to the hosts, so show host 1 or SSH host 1. I do interface EU1 through 2, channel group 1 mode active, interface port channel 1, switch port, no switch port, 10.1.10.11, ping 10 IP route 10.1.0.0, 10.1.10.1, ping 10.1.10.1, show interface port channel 1. Looks good. All right, and I can ping it. Sounds good. Sometimes it takes a little bit for that to ping. Host 2, U1 through 2, channel group 1 mode active, interface port channel 1, no switch port, IP address 10.1.20.12, IP route 10.1.21. 10.1.21. Show LACP peer, show MLAG, show LDP neighbors. Ooh. Wait. Yeah. Interface E4, channel group 4 mode active. Maybe that's why. There we go. There we go. I can ping. Should be able to ping the other side, the other host now, and I can. All right, so that's all done. It took a lot less time this time, so that was really truly a speed run. And so next is I want to configure the routing. That took a little longer because it's just kind of tedious. Let's do router BGP1, router ID 1111, and then maximum paths 2. SSHR1. IP routing, router BGP1, router ID 11, maximum paths 2. That is really annoying because I keep going over here and then it pops that out. I don't care about this. Like, stop doing that. How do I get it to not do that? That's a frustrating thing about VS Code. Well, I mean, one of the few frustrating things, but certainly a frustrating thing is I don't know how to disable certain things. Like when I'm moving my mouse and that thing pops up on the left, I don't know what that's called. And I just need it to not do that. All right, I'll be right back. Just need to take care of something real quick. All right. And we are connected to our host one, so we'll do the switch port IP address. We'll do 172.16.0.1/12. I like doing the 172s as like an external network. It's just a convention I use. And then the really tedious part is configuring the point-to-point interfaces here. I have to do that again. That's fine. It's a little tedious. Interface E1. No switch port. Interface E2. No switch port. PS 10150. Interface E2. 152. Okay, IP routing and router BGP1, router AD, maximum paths 2. PC1, IP address 10154. IP address 10156. All right, show DP neighbors on the spline. 7 and 8. Interface E7 and 8. No switch port. Interface E7. IP address 10151. E8 10155. So should be able to ping 10150. 10154. Okay. It's not too bad. Interface E7 and 8. Switch port. All right. So that's good. And then router BGP1. Switch neighbor core peer group, neighbor core remote AS1, neighbor 10150, 10115. I don't think you can do comma. Yeah. Peer group core. And so address family, IPv4, neighbor core activate, network 10110, network 10120. All right.
R1, neighbor spline. I think I called it core last time, which is weird. We should have called it that. Spline, peer group, router BGP. Let's do it all in one AS. See if that causes any problems. I don't think it will. For my R1. So that should be 1 and 3. Network. All right. All right, we're established. We're getting a route. Show IP route. And we got the routes. Okay, so that works there. We'll do this here. Router BGP1. Neighbor spline peer group. Neighbor spline remote AS. You can always add other stuff, but you have to set a remote AS, even if it's the same AS. Ask me how I know that one. Many times I couldn't get it up and running because of that particular issue. So neighbor. So I'm on R2, so my neighbor will be 5 and 7. Address family, neighbor, spline, activate, IP BGP summary, and established. We're not advertising any prefixes because we don't have any connected. It'll just be a backup route, basically. Oh, we didn't set up anything on this one, so this will be router ID and maximum paths 2. And neighbor core peer group. Neighbor core remote AS is 1. Neighbor, so the spline 2 would be 2 and 6. I think 2 and 6, yes. Then address family IPv4. I lose connectivity to that entirely. Oh, that's because I didn't connect R1 and R2 together yet. So that's another one I need to connect. So I need to come up with another IP address, 6 and 7. There we go. All right, so I should see from the spline, I should only see one path because the other path has more hops. But if I do show IP BGP 172.16.0.0, or what if I do interface E7 shut show IP route? Oh, oh yeah, so I shut that down.
Why is that route not coming through? Let's look at the map. So what I'm thinking should happen is the route from R1 should go to R2 over that link. So let me look at R2. And then show IP route. Do I not? And I do have maximum path. Do I need to configure a route reflector for this? I don't think I do. Maybe I do. All right, so host originates at R1. Our route originates at R1. Show IP route. So it's directly connected to it, and then show BGP summary. So I'm connected to. I haven't accepted any prefix, but I'm advertising one. So that should be the prefix I'm getting from there. Then show IP route. R2 is getting the route. But I'm not advertising any routes. I think it's an IBGP thing. Yeah, there's something I forget. Something I'm doing right. Just goes to show you how I've got some gaps in my BGP knowledge for show. All right, so what I think I'll do is I did the speed run, so we're good there. So let's talk about starting to wrap this up. And what I'll do is clab destroy. And I didn't save the config. See if it starts them up with the same config. I wouldn't have because I didn't do it right. Oh, God, gosh darn it. All right. Maybe we'll do it another time, but I think I'm done for today. Darn it. It's 2 rookie mistakes. But what I will do is I will commit this to the GitHub repo and then post it. So at least the topology will be there. The configs won't, but the topology will be there. Should have run that command right there. Let me get the backup configs stuff. Playbooks, backup configs. So if I go to Spline 1, yep, didn't save anything. Good on me. All right, so I will do this. Git add embedded Git repository. What the heck was that? All right, so it's on my GitHub repo. There's Spline. I will put, so there's the Ansible directory, and then CLab Spline. Oh, you know what? That's why. Let's do this. CLab destroy. Reconfigure. Yeah, that's fine. All right, I'm going to shut it down. If you watched through this, thank you for watching.